Yesterday, we learned about the equation for a direct linear relation. Today, we're going to look at an equation for a partial linear relation. Quickly, briefly, because I think you know this, but I would like to go through it. When you look at a graph and it's partial linear, it's a partial linear relation, what does this word tell us about the graph? It's a straight line. Aaliyah, what does this word tell us about the graph? Exactly. Direct goes through the origin, partial doesn't. So it looks like this. It's still going to follow the same rule in the table that if x is going up by 1 each time, then y might be going up by 5 each time. That deal is what's telling us that it's linear. The difference is it doesn't go through the origin. So for example, here's an example of a data table that would give us that kind of a graph. X, Y, 4, 12, 6, 15, 8, 18. Take a minute and use your calculator if you need to. Ask yourself if it's following that pattern that we talked about before, where x is going up by the same amount regularly and y is going up by the same amount regularly. So x is going up by 2 each time, y is going up by 3 each time. It's linear, correct? Let's check something out though. Let's work backwards. That would be a 2, wouldn't it? What number would be beside the 2 if y is going up by 3 all the time? 9? This would be a 0, right? Up by 2, up by 2. What number would be beside the 0? You know? 6, perfect. Look at that though. It doesn't go through the origin. It doesn't go through 0, 0. It's going to start at 6, and every time you go to the right on the graph 2, it will go up 3. To the right 2, up 3. To the right 2, up 3. So that's still linear. Anyway, that's what partial linear relations are. Today we're going to look at what the equation of this is. For direct, it was this. Okay, well, I'm telling you it's not that for partial, but we're going to learn what it is. Okay? So, 3 examples I want to get through today. What I've got for you here is the idea that you have a wooden box. It has a mass of 75 grams. And you're going to put marbles in the box. The marbles are 15 grams each. And we want to find the total mass for all of these numbers of marbles. Do you remember, I think it was Brennan's example of the logs on the logging truck? You remember that? And when we first did it, I said, are we going to include the truck? And he said, no, because that would be direct. But if we include the truck, that means when there's no logs, you still have a mass or a weight. It's the same kind of thing here. So what would the mass be with no marbles? Well, it would be 75 grams. What about with 2 marbles? Well, I want you to figure out what the total mass would be if we put 2 marbles in the box. Each marble is 15 grams, so you can take 75 plus 15 plus 15. Or you could say 2 marbles is 30 grams, so we can add 30 grams, which is 105. And I think you're getting to know me as a teacher here. It's not just about doing the math and the numbers, it's about understanding it. Alexa, can you tell us why this went up 30 grams? Right, because we've added 2 marbles. Right? It isn't just numbers, they mean something. So why do I know that this is going to go up 30 grams as well? We're adding 2 marbles. This goes back to the idea that you're adding the same number amount each time to x, so whatever y increases by, that has to be the same amount each time. So basically, once you figure that out, you can continue to add 30. And I'm doing this in my head, so I would like everybody to double check my math. You're getting the same numbers, in other words. Yes? Okay. And complete a graph. Okay. So here's the grid that we have to use. Again, I mentioned this the other day, and I was met with some puzzled looks. And then I mentioned it yesterday, and I didn't get as many puzzled looks. I hope when I present this idea to you today, I get even fewer puzzled looks. First of all, is this linear? Yep. Goes up by 2, goes up by 2, goes up by 2. Marbles, marbles, marbles. Goes up by 30 grams, 30 grams, 30 grams. It's linear. How many data points, how many of these do we actually need to graph so that we can draw the line? 2. Because it's a line. It's a straight line. As long as we get 2, we're good. Keep that in mind. So I have to graph this up to 10 marbles. I'm looking, well, maybe I better stop here. What's the dependent variable? What do you think?
The grams.
The mass, the grams. Because it depends on how many marbles there are. Where do we put the dependent variable, Daniel?
On the y-axis.
On the y-axis or the vertical axis. So this is going to be, let's use capital M for mass. Where are we told? I better be careful here. We're not told what letter we should use. So I'm going to call the variable capital M for mass. And then in brackets we can put grams. That means that the number of marbles goes down here. Usually we use n for a number of things, whether it's number of logs, number of cookies, number of marbles. And we don't really need to put units here because a number like 5 marbles doesn't have units, it's 5. The title is mass compared to number of marbles. And looking at the bottom axis, I think this works out beautifully. 2, 4, 6, 8, 10. And what's the biggest mass we have on that data table? 225? Well, this is great. Look at this. 100. 200. And you don't have to write these other numbers in, but if this is 100, then this is 25. This is 50. This is 75. And then 100. So 225 is going to be here. What's the mass? Well, no, I want to ask a different question. Looking at your data table and looking at your graph, is this a point that we can plot perfectly on our graph because we can read those points exactly? Yes, it is. 0 for the number of marbles is right at the beginning of your graph on the bottom axis, and 75 is here. This is a data point. Had I asked you this, is this a data point that we can plot perfectly on our graph? No, we can find 2 marbles exactly on the horizontal axis, but going up to 105 would be iffy. We'd kind of put a dot, I don't know, maybe there or there. It would be an iffy thing. So now I want you to continue to look down the list and find a second point that we can plot precisely. I think it's the last one, right? Everything else is like 135 grams, 165. Now, it doesn't always work out nicely that you have 2 points, but we do here. So we can plot 10 marbles is 225. And then we can take a ruler, and I apologize, I forgot to hand out the rulers. We can take a ruler, and we can draw a line. Let's see if this question that we've talked about, I don't know, 8, 10 times, let's see if everybody's got it now. Should we be drawing a solid line through all of this? If you draw a solid line, you're saying that the numbers can be anything on that line. Should we draw a solid line or should we draw dotted? Dotted. And could you explain why, Alexa?
You can't have half a marble.
Right, that's the perfect answer. You can't have half a marble, right? You can't have a third of a marble. You can't have 0.8 of a marble. Marbles can be 1 or 2 or 3. So I like to, when you do this, I like to draw a line that's dotted. Just because this is about math and not just this question, what was the mass when we had 2 marbles in it? Was it 105? Okay, well, if you look at where 2 marbles is, that means this is 105. So if you wanted to, you could put this point in here, but you don't need to. All right, there's the graph. What were we asked to do? Find the slope and the y-intercept. Okay, so we've only done the y-intercept thing a couple times. Ryan, do you remember looking at this graph what the y-intercept would be? 75, perfect. It's where the line crosses or touches the y-axis. So the y-intercept is 75 grams. How do we find the slope? Well, y minus y over x minus x, right? And you might notice something here, I don't know. I'm adaptable. I can go back to the triangle thing if you want from time to time. But I really want us to try the y minus y over x minus x. So this is at 0 marbles, 75 grams. This is at 10 marbles, 225 grams. So your slope will be 225 minus 75 over 10 minus 0. And that works out to 15. Am I right? 15 what?
Grams per marble.
Grams per marble. Of course it's 15 grams per marble because each marble is 15 grams. So we've got the y-intercept, which is 75. We have the slope, which is 15 grams per marble. We've answered the first question. Let's take a look at the next part. I'll just write it in here, 15 grams per marble. There's my marble. Y-intercept, 75 grams. Aaliyah, what type of relation is this? Partial linear. Perfect. And again, we've already reviewed this, but briefly, it's partial because it doesn't go through the origin. It does not go through the origin. And it's linear because it's a straight line. Now, what I'm asking you to do in C is I want you to come up with a way in which you could calculate the total mass using the number of marbles. Now, listen carefully, though, because I'm not asking you to continue this. What I'm saying is, what if I told you that there were 29 marbles in the box, or 295 marbles? Doesn't matter. I'm going to go with 29. So we can't just continue to add 2 each time to get an answer, because we're not going to land on 29. Is there a way for us to use the information in the question to calculate this number without looking at the previous numbers, without looking at the data in the table? Do you know?
You make the equation.
Which equation? There's no, I haven't written an equation yet, have I? Oh, you're one step, okay, you're right. Pretend you're not looking at the bottom of the page, okay? That's what we're learning here. How would we use this information to find the mass? Well, the total mass is the mass of the box plus the mass of the marbles, right? So the total mass is the mass of the marbles plus the mass of the box. Well, what's the mass of the box? 75, isn't it? What's the mass of the marbles? Just a second here. I'm asking you, what's the mass of any number of marbles? I'm not asking you for the mass of 1 marble or 2 or any number. How would you find the mass of any number of marbles? In other words, what if it was 29 marbles? What would you do to 29 to find the mass of 29 marbles? What'd you get? Did you calculate it? Take a chance. Tell me what you got. Think about that. Would 1 marble have that mass? No. You're thinking in the wrong direction, but we're on the right track. What you're going to do is take the number of marbles times 15. All right, just check this out. Would you agree that 2 marbles is 30 grams? So the reason it's 2 is because 2 times 15 is 30. So you're going to take 15 times 29 to get the mass of 29 marbles. If you had 47 marbles, you would take 15 times 47. And we're getting to the equation that makes that if we know the equation that you've already looked at, Daniel, it means we don't have to think about this anymore. It just happens. The bottom line is the mass of the marbles will be 15 times the number of marbles. So we have a formula now. This formula can be used to determine the mass no matter how many marbles are in the box. But I want you to notice something. Don't forget, this is our y. Well, I don't want that. This is our y. This is our x. What's this? I know it's how many grams per marble, but what is it in terms of the graph? It's the slope. And what's this? This is the y-intercept. And that's always going to be the case for linear relations. So we're going to get y equals the slope times x. Remember I said, I don't know whose brainchild it was to use m for slope, but we have to live with it. Remember? It's a weird choice for a letter. Well, somebody decided for y-intercept we're going to use b. And you will have learned about this in previous classes in high school, that b is the y-intercept. So when Daniel answered my question earlier, how are we going to get an equation? Daniel said, well, we're going to use the formula. And I said, well, which formula? And you said, well, the one that's at the bottom of the page. And this is true for a partial linear relation. The y is always the dependent variable. The x is always the independent. The slope of the graph is m, and the y-intercept is b. So if you know m and b, you have an equation that can be used to calculate things. I want to ask you a question, though. We'll get practice with this in a second. What's important about direct linear relations? What is important? It's a straight line, but what's important to make it direct? Do you remember? It's the origin. Can you tell me what the y-intercept of this graph is? It's 0, right? So direct has a y-intercept of 0. And we learned yesterday this is the formula for direct, isn't it? But look at what happens if you make b 0 here. You're left with y equals mx, which is the equation for direct. So this will work for everything. Compare your equation to the features of the graph. I have already done that. I just did it here, and I saw you write it down, so we're good. All right. Joseph is moving to St. Paul, Alberta. I taught in St. Paul for a few years. To attend Blue Quills College, he is taking the pre-trades prep training program. He's going to drive all of his stuff to St. Paul. He's rented a moving van or a moving truck, and the van rental is $45.95 plus 75 cents for each kilometer driven. Okay? Think about what that means. Does he pay the $45.95 if he rents the van and drives it across town? Yes. Does he pay the $45.95 if he rents the van and drives it to St. Paul? Yes. That's the flat amount. And what I'm trying to get at in this entire lesson is the following. The flat amount is going to be your y-intercept. Let's go back and look at our equation for marble mass. Okay? Look up here, please. There's our equation for marble mass. If n, little n, is 5 or 10 or 100, you're still adding the 75. That's fixed. That's the flat amount. If Joseph drives 20 kilometers or 400 kilometers, he's still paying the $45.95. That's the flat or fixed amount. So why will this be a partial linear relation? There are two reasons. Because each kilometer means this much more. I don't think we need to write a data table here. But if we did, if you went up 1 kilometer, it would go up 75 cents. Up 1 kilometer, up 75 cents. That part is what makes it linear. However, so this is what makes it linear. However, 0 kilometers, you still pay $45.95. What does that mean? It means it doesn't go through the origin. Imagine, and this is maybe not realistic, but Joseph goes and he goes to the budget rent-a-van or whatever it is, and he signs all the papers, and they take a credit card number from him for a deposit, and he's got the keys in his hand and his phone rings, and there's a family emergency and he's got to go do something else. Once you've made that agreement with the rental company, you can't just say, oh, I changed my mind. I know it might seem unfair, but as soon as the deal is done, and he gives back the keys, they're going to go, you know what? Sorry, man, you owe us $45.95. And what that means graphically is the graph is going to start here and be linear. And it will be linear after that point because each time you go up, I'm going to make the graph scaled weird. You go up 1 kilometer, it's up 75 cents. Up 1 kilometer, up 75 cents. That's what makes it linear. So it's a partial linear relation for those reasons. What's an equation you could use? Well, we're going to use this. I'm going to ask everybody to identify in that equation that I just wrote which of those letters would be C and which of those letters would be N. So, does the number of kilometers depend on his bill, or does the bill depend on the number of kilometers? Well, the bill depends on the number of kilometers. So this is our C. Our X is the number of kilometers. What do we multiply the number of kilometers by? 0.75. What do we add to that? 45.95. And you know what? You could probably come up with that equation even before this lesson, just reasoning out how your bill would be paid, or how your bill rather would be calculated. If a graph showed the cost compared to the distance, cost, number of kilometers, we know it would look like this. What would the slope be and what would the y-intercept be? I'm going to ask you because I might need to fix your handout. Does yours say what would the y-intercept be? Does it say y-intercept on yours? Okay, good. So what would the y-intercept be? Well, that would be when you drive 0 kilometers, what your bill would be, which would be $45.95. Your y-intercept is that. What's your slope? Well, we don't need to think of this graph because the answer is right here. B is the y-intercept, 45.95. M is the slope, 0.75. So your slope would be 0.75. Are we okay with C? Okay, D. I'm going to ask a different question first, and this is not in your handout. You can write this down if you like, but you don't have to. What if he drove 600 kilometers? Would you be able to find out the cost that he's going to pay? I hope so. And you would use the formula. You would say, well, the cost is 0.75 times the number of kilometers plus the 45.95. So even though this isn't a question in your notes, I want everybody to calculate what that's going to be. And I'm doing this in my head, so there's no guarantee it's right. I'm pretty sure it's 495.95. Am I right? So I'll give you a second to catch up, those of you that are still working on it. You're going to take, I'm sorry, I should show you what's going on here. You're going to take 0.75 times the number of kilometers, which is 600, plus the 45.95. And I'm getting 495.95. Yes? Okay, good. I don't have an example like this in your notes, but that's a good question. You need to know how to do it. This question, though, is this. Right? And try to listen carefully to what I'm about to tell you. When you know x, it's easy to find y, because your equation says y equals. When you know y, it's harder to find x. But we're going to take this equation, cost, which is our y, equals 0.75 times x, which is our number of kilometers, plus 45.95. And when we did this question off on the side, everybody, what I did was I put in for n 600 because that was n. Here, what I'm going to do is put this in for the cost because it's the cost. So now we have 252.20 equals 0.75 n plus 45.95. And we need to take a pause here. By a show of hands or a nod of the head, how many of you know how to solve this equation for n? A couple of you are iffy, that's fine. What if I gave you this equation instead? How many of you know how to solve that equation? And I think more of you know how to solve this because it looks like something you would do in a math class, right? It's what I call a two-step equation. You have to subtract 7 from both sides first, giving us 21 equals 3x. And then what would we do to both sides to get x? Elijah, what would we do to get x here? Yeah, perfect. Divide by 3. So now you would divide both sides by 3, and we end up with x equals 21 over 3, which is 7. Okay? That's how you solve these types of equations. So in this question, what we are going to have to do is subtract the 45.95 first from both sides. So you learn how to do these in junior high, and in grade 10 and 11 math, you work with them as well. What do we have? I need your help here. 206 point, when you subtract them? No? I better just grab my calculator. $252.20 minus 45.95, 206.25. And then I have to divide by the 0.75. And I get n equals do that again. Divided by 0.75, 275 kilometers. And that's the answer to the question. Why don't we have lots of time. I don't want to rush today. Can you do me a favor and just double check? If you put 275 kilometers in here, what do you get for the cost? I mean, you better get, what was it? You'd better get 252.20, and you do. Okay. All right, one last example. Anjali is an events coordinator at a banquet hall. So what she does is she arranges banquets for weddings. She's arranging a wedding reception for a couple who's going to get married. They don't know how many guests they're going to have. So what they do is they ask Anjali to tell them what the range of costs would be if they went anywhere from 50 to 200 people. And Anjali shows this graph. Okay. That is not what this couple is going to use. The couple might have 100 people, they might have 28 people. We don't know. But this shows the cost for a large number of different couples that would get married. What's the equation relating cost to n? Okay, wait a second. Cost is y. N is x. Is this linear? Look at the graph. Is it linear? Is it partial? Because it doesn't go through the origin. That means if it's linear and it's partial, then this is the equation. I mean, I'm not saying we're done. That's the equation of every partial linear relation in the universe. Ryan, looking at the graph, what is y? I'm not looking for a number. I'm looking for a word. Well, you're thinking of the y-intercept. I'm just saying, what is the variable on the y-axis? What is it? Is it number of bananas? What's plotted up here? Cost. So this is the cost. And what you told me is the y-intercept, I think. We'll get to that in a second. Phoenix, what is plotted on the horizontal axis? What's x? The horizontal axis is this bottom axis. Number of guests, so n. And what I'm getting at is that when you look at the graph, the thing on the y-axis is cost, the thing on the x-axis is the number of people. Ryan, now, what's the y-intercept? 500. So we look at the graph, we say the y-intercept is 500 because this is 2,000, this is 1,000, it's crossing at 500. And we're going to put 500 in here. Why? Because that's the y-intercept. What's the only thing we're missing that would complete the equation? Slope. Well, you know how to find the slope. Pick 2 points. Y minus y over x minus x. It doesn't matter which points you pick, everybody. And you can choose the points I'm choosing, or you can choose 2 other points, as long as you can read them correctly. So if I choose those points, it's 50, 2,000 and 150, 5,000. So my slope is y minus y over x minus x. And if you did choose 2 other points, you're still going to get the same slope. Daniel, have you already got the slope calculated for us? What is it?
30.
30? Okay. Which means the slope is 30. So our equation is cost equals 30 times number of people plus 500. Let me write that equation down. And I'm going to ask you, I'm just writing it without the highlighting. I want you to see if you can come up with, well, let me just ask it. Y plus 500.
Because that's the starting point, like the, I can't remember the word.
Y-intercept?
Yeah.
True, that is right, but I'm asking you in terms of this person's job, what's the $500 charge? What is that? And it is the starting point. Oh, I know the word you're thinking of, or you're trying to get. Flat rate, fixed cost. Got it. Okay, I know where you're coming from. That's going to be no matter how many people this person caters your wedding for, they're going to charge you $500. Why? Hall rental, laundry service for the tablecloths. I don't know. It doesn't matter. It's a fixed cost. Why is it 30 times the number of guests? What's the reason behind that? And by the way, this is an example from a few years ago with inflation and the price of things. That number would not be 30. It would probably be 80. What's the deal with that?
That's the cost for each guest.
That's the cost for each guest. Perfect. And you know what I didn't do, and I didn't do it intentionally? Every time we calculate slope, every time I've said to you, 30 what? And I didn't do it this time. What is this? What are the units? It's dollars per guest.
Aaron Charlton, the office. Aaron Charlton, the office, please.
It's dollars per person. So that equation should make sense. You're going to take the number of people that you're catering the event for, multiply by $30, because that's the food probably, and then you're going to add the flat rate. So now we just have a couple more questions and then we're done, but you're going to practice. What would the cost be for 115 guests? So let me write out the formula. And let me ask you a question. I know some of you are way ahead of me, but hang on. Could we answer this question by locating 115 here and reading the answer from the graph? Yes. Would it be accurate? Where's 115 on here? Would you be 100% sure you knew where it was? No. So that's why we have a formula. This is a case where you know n and you're trying to find the cost. Easy. When you know x and you want to find y, all you do is you feed this number into the equation and calculate it. There's no rearranging. I want to say 3,950, but I'm doing that in my head. Is that is right? 3,950? Dollars. Now take a look at C. If they had this much money, 5,500, and they said, you know what, between you and I, let's agree to spend this much money, no more. How many guests could they invite? So this time we have this formula. We're still going to use the equation or the formula, but this time we know the cost and you're trying to find n. This is found in the same way. You take this number and you feed it in where it belongs in the equation. It's just that it's more work to calculate what the other variable is. But you are going to do the same thing we did before. You're going to subtract 500 and then you're going to divide by 30. So minus 500 from both sides, which is 5,000, equals 5,000 equals 30n. And we take 5,000 and divide by 30. Sorry, I should be showing all of my work. 167.66666.
166.
Exactly 166?
166 repeating.
Oh, yeah, thank you. 166.66666. Okay. Okay. I'm going to come back to that. I like to get my students to think here. It's not just about doing the math. What's wrong with their graph? I mean, there's something technically wrong with it.
The line should be dotted.
The line should be dotted. You can't have part of a, I mean, I don't know what that means to have half of a wedding guest. You've got bigger problems than arranging your wedding ceremony if you've got a relative who's only half a person, right? So the question becomes then, since this is supposed to be a number of people, we have to round. But I don't know that you've ever run into this before. You would be taught, well, you're going to round up because this number is 5 or more, so you're going to round up. But who can explain to me why it's actually 166 wedding guests, not 167?
Because if you rounded up, you would have to pay more because that's an extra person.
Right. That's mathematically the number that takes you to 5,500. So if you say 167, then it's more than 5,500. So we have to round down. Now, let's be honest, though. I mean, if you had that one person, you know, old friend from school that you hadn't seen in so long and you wanted them there, you might go, well, it's only going to be a few more dollars. Let's invite them. But technically, we should be rounding down. This lesson is all about partial linear relations, and their formulas will all be that. We've slowly crept in some algebra here. I didn't draw your attention to it, but we're doing some algebra. But the bottom line as a partial linear relation looks like that. The slope and the y-intercept tell you the equation. The y-intercept is this number. The slope would be rise over run, or y minus y over x minus x. So you have 3 problems that I would like you working on for Monday. 12, 13, and 14. These are all on page 30 of your unit handout, so you don't need your textbook today. Any questions? Does that make sense today? Followed along okay? All right. In the words of my mom, pitter patter, let's get at her.